Hello and welcome to this video on roots of quadratics. This is part 2. In part 1 we looked at roots for x squared plus bx plus c is 0, and now we're going to include a coefficient for x squared. So in general, if ax squared plus bx plus c equals 0 has roots alpha and beta, then alpha plus beta is given by negative b over a, and alpha beta is given by c over a. And the question we are being asked is to find the value of alpha to the power 4 plus beta to the power 4 for the equation 2x squared equals 6x plus 3. So we need to find the values of alpha plus beta and alpha beta. And to do that, we start by writing the equation in the form ax squared plus bx plus c is 0 by subtracting 6x from 3 to get 2x squared minus 6x minus 3 is 0. Then alpha plus beta is given by negative b over a, which is the negative of negative 6 over 2, or 3, and alpha beta is c over a, which is just negative 3 over 2. We can start the process for alpha to the 4 plus beta to the 4 in the same way that we did for squares and cubes in the previous video. So using the binomial expansion, alpha plus beta to the power 4 is given by alpha to the 4 plus 4 alpha cubed beta plus 6 alpha squared beta squared plus 4 alpha beta cubed plus beta to the 4. And then by making alpha to the 4 plus beta to the 4 the subject, and getting everything in terms of alpha plus beta and alpha beta, we end up with alpha plus beta to the power 4 minus 4 alpha beta multiplied by alpha plus beta squared minus 2 alpha beta, subtract 6 lots of alpha beta squared. And now we can substitute alpha plus beta is equal to 3 and alpha beta is equal to negative 3 over 2, and we get a final answer of 279 over 2. So now it's your turn. I'd like you to pause the video. You've been asked to find the values of alpha cubed plus beta cubed and alpha to the 5th plus beta to the 5th for this equation here, 2x squared equals x plus 4. We have already considered alpha cubed plus beta cubed, and again you can use the binomial expansion to investigate alpha to the 5 plus beta to the 5. So for the solution, we start in the same way and we find out that alpha plus beta is given by a half and alpha beta is given by negative 2. As I said, we have already investigated alpha cubed plus beta cubed, but using the same process, we end up with 25/8. And then for alpha to the 5 plus beta to the 5, again, I've used the binomial expansion, I've rearranged it, and I've rewritten it in a form that we can use, including alpha cubed plus beta cubed, which we've already evaluated as 25/8, and the final answer is 361 over 32. And now for the same equation you've already used, 3 extra questions, 3 extra expressions to evaluate. Please pause the video. So for the first one, I've evaluated 4 minus alpha, 4 minus beta, and which is 12, and then I've substituted that into the square root of 3 lots of 12, which makes the answer of 6. For 8 over alpha squared plus 8 over beta squared, I've added the fractions together, and we already know how to work out alpha squared plus beta squared. So substituting everything in, we get an answer of 17 over 2. And then finally, for 128 over alpha cubed plus 128 over beta cubed, again add the fractions together. And we've already evaluated the fact that alpha cubed plus beta cubed is at 25 over 8. So substituting in, we can get a final answer of negative 50. Of course, if you needed to, you could work out alpha cubed plus beta cubed from scratch. Thank you very much for listening, and good luck.